In this video we shall discuss how to manage transactions isolation levels. First, we have to emphasize that for the next several solutions to work, you have to execute each query in a separate session. As in most cases you may not use your typical client software. That's because it usually works in a single session, even with multiple windows opened. But there are two good and simple solutions to this problem. You may either use console client for your DBMS and open several copies, or you may write a simple program in your favorite programming language and launch one instance for each of your query. Let's proceed with tasks, and in the first one we have to write two SQL queries that with simultaneous execution behave the following way. The first query should increase all subscriptions and dates by 1 day and never wait for completion of any selects on subscriptions table. The second query should read all subscriptions and dates and never wait for the first query completion. The expected result for this task is that with each start combination, either the first query then the second or the second query then the first, both queries work simultaneously, no query is waiting for another one's completion. By the way, if you are not too familiar with transactions isolation levels and so on, please refer to this course for details. Let's start with MySQL, and here is the solution for this first point. In each query for each DBMS we have to make sure that we are working in different sessions. That means that this identifier should differ from the identifier of the session of the second query. Then we have to turn off the auto-commit for implicit transactions, then we have to start the transaction explicitly, and then we have to update the data. Finally, we only have to commit this transaction. If you want to execute this query and the second one manually, you may uncomment this string and it will give you time to start the second query. And while you're repeating the whole experiment yourself, please remember that in MySQL with InnoDB engine, queries that modify data always have priority over queries that read data. For the second point, we have to create such a code. Here we also have to get this ID and make sure that this ID differs from the one you get with the other query. Then we have to turn off the auto-commit for implicit transactions, and then we have to set this transaction isolation level to read and committed. That's how we solve the second point of the task. It is how we make this query to never wait for any other query completion. And finally, we just have to start the transaction, to select the data, and to finish the transaction. With Microsoft SQL query, the idea is the same. This is the code for the first point. Here we also have to select this ID and make sure it differs from the one you get with the other query. Then we have to turn off the auto-commit of implicit transactions, then we have to begin the transaction, to update the data, and to commit the transaction. For the second point, we have to write the following code. Here we also have to deal with this ID and make sure that it differs from the ID of the first query. Then we have to disable the auto-commit of implicit transactions. Then we have to change the transaction isolation level to this. And that's how we solve the second point. It is how we make this query to never wait for other query completion. Finally, we only have to start the transaction, to select the data, and to commit the transaction. For Oracle, the basic idea is the same, but there are some differences. In this DBMS, the only way to start a transaction is to execute a command that modifies data. That's why we just have to commit any previously active transaction, we have to select that ID and make sure it differs from the ID of the second query, then we have to perform update operation and to commit the transaction. To solve the second point of the task, we have to write the following code. Here we also have to commit any previously active transactions, then we have to deal with the session ID, then we have to switch the transaction isolation level to read committed, and then we only have to select the data and commit the transaction. Please pay attention that in MySQL and Microsoft SQL Server we were using uncommitted here, but no uncommitted exists in Oracle. That's because Oracle does not support uncommitted reading at all. For the second task, we also have to write two SQL queries. Both of those queries should count active subscriptions for each subscriber, but the first query should return the result as quick as possible, even if the data is not accurate, while the second query should always return accurate data, even if it takes some time. The expected result here is that the first query never waits for any other query's completion, while the second one may wait in a queue for some time. So here is the first query for this first point. Once again we have to deal with this session ID, we have to turn off the auto-commit of implicit transactions, then we have to set the transaction isolation level to read uncommitted. That's the lowest, the quickest, the dirtiest transaction isolation level in MySQL. Then we only have to start the transaction, select the data, and to finish the transaction. The only difference in the solution for the second point is here. To always return most accurate data, we have to use this highest, slowest, but cleanest transaction isolation level for MySQL. With all other details, this query is just a copy of the previous one. But to test this solution, we have to create another query. This one changes the status of a subscription from active to inactive and from inactive to active. And this information influences this selection result. Then we have to run this query simultaneously with the first or the second query to test their behavior. Or we may even execute this query simultaneously with the first and the second at once. With Microsoft SQL Server the idea is the same. We also have to deal with the session ID here. Then we have to turn off the auto-commit of implicit transactions. Then we have to set the transaction isolation level for read uncommitted for the first point of the task. Then we have to start the transaction, to select the data, and to finish the transaction. This transaction isolation level allows us to get the result as quick as possible, even if the data is not accurate. The second query for the second point is the next. The only difference here is this. Here we have to use serializable transaction isolation level. This is the highest, the slowest, but the cleanest transaction isolation level in Microsoft SQL. So this query will produce the most accurate data. In all other details, this query is just a copy of the previous one. And like with MySQL, to test these queries properly in Microsoft SQL Server, we have to create an additional one. We may run this query simultaneously with the first or the second, or even with them both at once. Inside the query, we are changing the status of a subscription from active to inactive and from inactive to active, and we may investigate how this influences the behavior of the first and the second query. For Oracle, the general concept is the same, except for one difference. As in this DBMS we cannot start a transaction manually, we only have to commit any active transaction and wait for any data modification operation to happen. Then here we have to deal with this ID and make sure that it differs from the ID of the second query session. Finally, we have to change the transaction isolation level to read committed, we have to execute the data reading operation, and we have to finish the transaction. So in Oracle, this transaction isolation level is the lowest but the quickest, so it will return the result as quick as possible, even if the data is not accurate. Like with MySQL and Microsoft SQL Server, in this second query, the only difference from the first one is here. To achieve the most accurate data, we have to use serializable transaction isolation level. It is the highest but the slowest one. In all other details, this query is just a copy of the previous one. And of course, to test our solution properly, we have to create another code. Like with MySQL and Microsoft SQL Server, we should run this query simultaneously with the first or the second query to test their behavior. Inside we are only changing the status of each subscription, but as this information influences this result, execution of this query simultaneously with the first and the second will allow us to investigate their behavior deeper.